Number 9 is another problem we're going to have to sketch out. And if we start reading it, it says a 20-foot support post. And the keyword is leans against a wall. So I'm going to draw a wall. That's a terrible wall. Okay, I'm going to call it WALL. I'll throw some bricks in there. Looking good. Got some bricks. Okay, it's a wall. And then a post is something that props that thing up. It offers support. And the idea is when a force from the other side pushes on that wall, the wall just doesn't crumble over because there's this support post propping it up, holding it up. That's the point of a support post. So part of dissecting this problem is knowing how to draw it, and we're kind of seeing and exploring how to draw it. And notice how I'm labeling everything: post, wall, and then it says, yeah, that post that's leaning against the wall, it makes a 70-degree angle with the ground. So the ground obviously goes on the bottom, because that's what the ground is. Now I'm going to start labeling numbers. The thing that's 20 feet is the support post. It is that green piece, that is the 20 feet. The other piece of information they tell me is that angle is 70 degrees. What they want to know is to the nearest tenth of a foot, so I'm rounding to a tenth. They want to know how far up. How far up, so whenever you hear up, you should be thinking about that height. How far up the wall will the support post reach? So we're solving for height in this problem. So we're solving for the height of the wall. Well, all walls make a 90-degree angle with the ground. That's how I know this thing is really modeled by a right triangle and an angle. So this is like trig. Here I'm going to label the hypotenuse, the opposite, and the adjacent. So my post is the hypotenuse, which I'm going to use. The x is what I'm looking for. That's the opposite side because that's opposite my reference angle. And I know nothing about the adjacent, and I don't care to find out anything about the adjacent. It's not involved in this problem. So I'm looking for the trig function that's going to use the opposite and hypotenuse. And we're going to write that out. So, ka, and toa. Right off the bat, you can see that's a sine type thing. So that's the sine of my angle, because I'm finding the side, so I'm going to use that angle with the trig function to tell me something about my sides, specifically the opposite divided by the hypotenuse. My opposite is x, so that goes on top because it's the opposite, not because the variable has to go on top. It's simply because x in this particular problem is the opposite side. And that 20 is going to go on the bottom because it is the hypotenuse. We'll butterfly multiply, we'll get an x, I'm going to bring down the equal sign, and I'm going to write this as 20 times the sine of 70. And I can read from right to left and see that it says x equals 20 times the sine of 70, or sine of 70 times 20. Either way is fine. So there's no work to be done. This is just typing into the calculator 20 times the sine of 70. You're going to see it's 18.793. X equals 18.793. And then I'm going to round based on how they asked me. And they want me to round to the nearest tenth. I'm going to come down here, find the tenths position, look to the right. Because that's 5 or higher, I'm going to round that 7 up to 8. This would be 18.8. I'm going to emphasize that decimal point.